Yeah. So everything I just said is written right here. This, like I say, will come with practice. I do it all in one go, but you don't need to, because you can do all your work and then you can just square root your answer. Everybody cool? All right. Now you guys are well aware that often we need to find angles as well. And you will notice that in the cosine law, here, if I need an unknown angle, which I'm going to draw in red or blue, if I need an unknown angle, then where in this law does that angle exist? It's the big C, right? So at some point, I will need to shift cosine to get that. But how do I get that? I algebraically rearrange. Rearrange to solve for what? Well, it's hard to rewrite solving for C. So we have algebraically rearranged to find cos C. Then we shift cosine. Again, you can do it all at once. Now, most people screw this up when they're rearranging it. If I'm going to rearrange this, c squared minus a squared minus b squared, easy, nobody has any problem with that. But then what do I have to do with this part? See, everybody says add because they see that negative there. But this is all multiplication, isn't it, Nav? So what do I do to get rid of it? Divide. So I've got to divide by what? No. Negative 2ab. All right? No. It's okay. It looks weird, right? That's why I'm doing this now and not saying, okay, guys, you know how to do it, and walking away, because all it is substituting numbers in, right? I'm showing you, and that's going to get you cos C. Now, listen to me, please. I'm not going to write this down. A lot of people screw this up trying to do this way. Okay? Remember, you have the option to plug all your numbers in here and then move it around if you're better at that. Does everybody understand what I mean? Right? Like when you were learning Pythagoras, your teacher said, oh, it's a squared plus b squared equals c squared, or it's c squared minus b squared equals a squared, or it's c squared minus a squared equals b squared, right? But some of you have always been more comfortable with that very first one, just putting in the numbers and moving it around once it has numbers. That's okay to do here too. Okay? Everybody cool? All right. So sine law is great when we don't have a 90 and we have a pair. Cosine law is great for both of these cases. Okay? So all three sides, then we're finding an angle. We can find an angle or a contained angle. Side, angle, side. All right? The green one is this. And the yellow one is this. Everybody cool? So, if you could all grab your calculators, and please make sure they are in degree mode. Let's work this one through. Now remember, I personally always find trig easier when I draw a triangle. Do I have to draw a triangle that actually matches the information given? Of course not. I do not need a protractor and a ruler. I don't need any of that. I just need to know the rules of naming stuff, right? So I have triangle ABC. AC equals 20. Is that a side or an angle? That's a side. BC equals 11. Is that an angle or a side? Side. And since it's AC and BC, where do these sides meet? They meet at angle C. And then angle ACB, since the C is in the middle, that is my big C. And that is my 20 degrees. So in this case, I have side, angle, side, don't I? So am I using the green or the yellow? I'm using the green one, right? Okay. So I know I'm using C squared equals A squared plus B squared minus 2AB cos C. And all I got to do is fill it in. C squared is what I need, yes? So I'm going to draw it. There's my 20. There's C. Does it matter about these two? Which is which? No. So that one looks a little bit longer, just the way I drew it. So I'm going to make that 20. I'm going to make that 11. Then I'm going to come down there. This is little c. Everybody cool? And now I just fill it in, and then we're going to do calculator practice, because that's really the hardest thing about sine and cosine laws, getting it through on your calculator. So c squared is what we don't know. What's a squared? Does it matter? No. Why doesn't it matter? Because I'm squaring and adding. So order doesn't matter. Would it matter if I was doing the yellow one? Why? Because yellow one's subtraction, right? You got to be careful. But this one isn't. So I got 11 squared plus 20 squared minus 2 times 11 times 20 cos 20. Now, to punch that into your calculator isn't difficult. To punch it all in and get the square root in one shot is a little difficult. If you are going to attempt this all in one shot and you have a forward calculator, it's not that difficult. You hit the square root button, then a bracket, and then you enter that in exactly as you see it. Except you may need to push minus 2 times 11 times 20 times cos 20. But you might not. Depends on your calculator. And if you have a backwards calculator, then you're kind of weird. It's not a big deal, except when you get to the end, you have to push negative 2 times 11 times 20 times 20 cos equals, and then square root it. Okay? So everybody punch that in and see what you get. I'm not going to use the calculator on the screen because this is a real pain to do with the pen. I'm going to use a big calculator and just put the number up. And if you need to see it, I'll use the big one on the screen. Okay? Has everybody given it a shot now? And so people have an answer for me? Mm-hmm. So who has an answer for me? 10.4 is also what I got. Is everybody cool with that? Right? So, have I done what I have sought out to do? I have AB, but I don't have ABC, do I? Well, where is B? Is it the end of 20 or is it at the end of 11? 11. Because BC was 11, right? Okay. So this is the angle for which I seek, right? Now, do I have a pair? So what do I do now? Sine law, 'cause I've got my pair right here, yes? Now, how many of you are looking at your calculator right now and the screen has 10.4, blah, 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 all the numbers? You've got it on your machine there, right? You know you're going to use it again. Should you clear it? No. because you're going to use it again. Can you use 10.4? Yes. But if you leave the whole big number there, you're going to get a more accurate answer. Because some of you will tell me that I'll give you a multiple choice question. You'll do a bunch of work. It'll come out to 26.1 on your calculator, and I'll have 25.9 on the answer sheet, and you'll tell me that the right answer isn't there. But that's only because I didn't round off in the middle of the question, which I have warned you guys against doing probably about 100 million times, right? So yes, we have written 10.4 here, but we should not use it if we can avoid it. We should use the most accurate number that we can until the end, right? So we all know we're going to do sine law now, and our sine law to find b is sine 20, and I'm going to write 10.4, but I know it's that big number that's on my machine, yes? Equals sine what? Sine b over what? What's sine b's, buddy? 20. And then we just cross, right? Right? So now you're in trouble, because when you've set it up, you know that you need to go 20 sine 20 divided by 10.4, yes? And you can see that 10.4 on your machine, right? But if you do this in order, you're not going to be able to use that 10.4 unless you're good with that answer key on your calculator, right? Because that answer key will always bring back the last thing you hit equals for. So if on your calculator to do this, you were to push 20 times sine 20, right, in brackets, and then you were to push divided by the ANS key, and then equals, you would get the right answer. But if you're bad at doing that, then use your rounded one. But understand the math enough to know that if you get, what do you get? I haven't even done this question. Huh? 20 sine 20 . Okay. Button errors. Okay. And of course you need to make sure you're in the right mode, right? So that was a 20 sine 20. What do you get? 41. That's what I have too. Why is 41 wrong? Huh? Why is it a reference angle? So this, if this is 41, then what's this? This would be 119, wouldn't it? Okay, is that okay? Why? Not across from the biggest side. Do you see what I'm saying? No, it's not a calculator issue. This is what we talked about yesterday, right? Or not yesterday, because yesterday was Sunday. Somebody do the joke. Thursday, we talked about this, yes? Those weird trig triangles that can be one or the other. Is this one of them? How do you know? By doing exactly what Lucas did. You've got to check. This makes no sense to have that be 119, does it? Right? Can't be. So what's this guy? Now, how do you check it, or how could you check it? What happens on your calculator when you do sine 41? What do you get? What? 0.65, yeah? Sorry? Yeah. All right, so is everybody cool here? You just got to check your stuff. Yeah? Yeah. All right, what's next? Well, okay. When Lucas said it was the reference angle, I figured everyone was okay. What is it? It can't be 41, so what is it? Which is? What? 138. So I assumed when Lucas said that, everything was going to be okay. Is it? Okay. Is everybody good? Because it can't make sense. Everyone's okay? All right. Now, the other thing, now I'm going to leave it like that. That's messing with you guys. All right. Let's look at the next one. What's weird about number 2? You have all 3 sides and there's different letters. Right? So let's draw it. What's the longest side? 10. So there's 10, and that's P to Q, yes? R to P is 7, so I'm going to make that 7. And then I'm going to make that 8. Is everybody okay with that? P to Q is 10. Oh, I have 2 P's. R to Q. P to 2 is 10. P to Q is 10. P to R is 7. R to Q is 8. Everybody good? Did I have to draw it this way? Did I? I did not have to draw it this way, did I? Okay. Since I am looking for an angle, right, which one am I going to use? The yellow one or the green one from the previous page? The yellow one. Now, can I fill it all in and move it around? Yes. That's totally fine too, right? But it doesn't really matter which one we do. So since I need angle Q, and the way we've written this out says cos C equals, right? That would mean what would Q be? C. So we should be able to handle this, yes? Okay. So let's start. What is C? Because cos C, which is Q, should be C squared minus minus, right? So what goes first? What is the C squared here? 7 squared. And then what? 8 squared and 10 squared. Now here does it matter? The next 2 don't matter. Does the first one matter? Yes. If you set this up wrong, you're in trouble. Correct? If I have 100 and I take away 10 and then I take away 20, I end up at 70, yes? If I take away 20 then and take away 10, I end up at 70. But if I start with the wrong number, I'm messed up, right? I gotta remember to start with the correct number, the one across from the angle with which you are dealing. Yes? So these 2 don't matter, so 8 squared minus 10 squared over negative 2 times what? 8 and 10. And then what am I going to need to do at the end of all this? Shift cos, right? So go, what do we get? Yo. Minus 49 minus, not 100, I did 64, over negative 160, yes? Now just to show you, you're not going to do all these steps, of course, are you? I'm just showing you. That's going to be a negative 115 over negative 160. Two negatives make a positive. Punch that in, and what do I get for a cos? $44 sounds about right. Second cos 115 divided by 160, 44 degrees. Now, this time, I thought about my triangle, didn't I? Right? I thought about how I drew my triangle. This is what it would have to look like, yeah? Since this side is longer and these two are shorter, this has to be the obtuse angle, yeah? And since these two are fairly close, it's got to be pretty close to a 45, 45, 90, doesn't it? Right? Are we pretty close to a 45, 45, 90? So we're okay. Is everybody good? Is everyone okay? All right. Okay. This, I don't know if I've told you guys about this question, but I have given this in the past and had a kid say that the airplane was 34,450 kilometers east of the tower. Some people are saying, oh, because I hope they get the joke. It's WestJet Flight 344 that is 50 kilometers east of the tower. If your plane was 34,000 kilometers east of the tower, it would be halfway to the moon. Okay? Your Alaska Air flight to LA does not go 34,000 kilometers. So I'm just fixing that up right now. The distances are highlighted. I didn't know what the kid had done because the kid had written all their numbers out. And it was, and I was like, 34,000, what, kid? And then I looked and I was like, oh, I get it. But of course, that's not how we write numbers, right? Numbers go in chunks of 3, not 50 and then new ones. So anyway, so why is this difficult? Because this is a real life version of what we're doing right now, yes? If you were plotting stuff on a map, you don't have A, B, C, D, Q, F. You have this boat or this building and this, you understand what I'm saying? So you got to be able to sort this out. So let's sort it out. Flight 344 is 50 kilometers east of the tower. So I should start with the tower, shouldn't I? There's my tower. Where is Flight 344? How do we usually draw east? To the right. 50 km. And here is Flight 344, yeah? Okay, now, some other flight is 25 kilometers from the tower. Does that other flight's direction matter? No. As long as I make it, boom. Here is Flight 712, and he's 25K away. Yes? If the angle between the two planes is 20, How far are they from each other? So what side do I need? I need that. Now please notice I haven't put any A, B's, or C's on here, yes? So how do we solve it? You could put A, B, and C. Where would you put big C? Big C? Big C is the angle. Where would you put big C? Where T is. And where would you put little c? Across from that where the x is. And now can you solve this? By doing what? Putting it into the equation and using your calculator. What's the law? C squared equals, what are the other two? 25 squared plus 50 squared minus 2, 25, 50, cos 20. And then what do you got to remember to do at the end? Square root, right? So you're going to do all this work, you're going to get a number on your calculator. If you're good with your calculator, you can square root at the very beginning, right? But if not, you may have to work this out. That's cool, it doesn't matter. Who has an answer for me? I'll be working on it right here. Who has an answer for me? To how many decimal places? Let's go with just one because I'm lazy. Kelvin. 27.9 is what I got. Now, let's check. Does that make sense? Does it make sense? This has to be the biggest angle, yes. It's definitely across from the biggest side. So I'm probably okay. Is everybody good? All right. You guys look at 4 and see if you can figure it out. Subtract it. You subtract it. It's added. Because we're doing this version. So that's why you got a weird number. No problem. So how should I draw this? I'm willing to help with the drawing if people need it. Start from the harbor. Ship A goes how far? 13. Ship B goes how far? 24. Right? That would make this 10, correct? Everybody good? And that makes this C, yes? Won't matter. So since I need the angle, this is a cos C situation, yes? Right? Which means what goes first? 10 squared minus, order doesn't matter, over -2 times 13 times 24, yes? Everyone agree? Okay. What happens when you punch that in your calculator? And of course, what do you do to that big, huge number? And when everybody is making the face Kelvin is making right now, I'm going to talk about the problem. And the face Joel is making. And the face Nav is making. Nav's just making a face. The face that Sydney's making. She looks like Rabbit in Winnie the Pooh when he finds out that Pooh is stuck in his back door. Nav didn't know who Winnie the Pooh was? Stegosaurus. Triceratops. Tyrannosaur. All right, so guys, why are your classmates making funny faces? Because it gets an error. Why? That's what you think. You did something wrong, doesn't it? How many of you hit that button, saw error, and said, what did I do wrong? How many of you? Be honest. All of you. When you do this math, you end up with 100 minus 169 minus, trying to think, 576, right? 576 over 2 times 13 is negative 26. 26 times 24 is 600 and what? 624. So that is negative 645 over negative 624. That's a number bigger than 1, isn't it? Can coses ever be bigger than 1? No. So what does that tell you about this situation? That it is an impossible triangle. You cannot have this set of parameters. So why did I give it to you? No, it's the complete opposite of that, Sydney. It's to prove to you that when you do all the work, if you know you've done the work right, you know you're right. You all are able to punch this into your calculator, aren't you? Right? Except Nav, apparently. That's why I don't assign this one as homework, Sydney. That's why this one is in the notes. What I should have done is given your first trig cosine law quiz with just that question. This question asks everything about cosine law you need. You have the entire 80 minutes. Beep, I need more time. Yeah. Some of you would actually die. It would be the awesomest thing. Your entire trig mark is this question. And there's only 6 units in the course, so it is about 20% of your entire grade. If you can't answer this, you might as well leave now. Because, you guys, honestly, I want you guys to get to the point where you stop doubting yourself. Right? You gotta get there. Alright. Okay. Do you like my drawing? Do you like the sketty, I'm gonna call them birds? But they could be bats, right? Ooh, they could be vultures circling for dead bodies. I agree. All right. How are we going to do this? We're trying to figure out the height of the tower, but I can't get close enough to measure it. See, if it were me, I would want to climb up here, right? And then rappel down here, and then measure the chord. But I can't because it's been fenced off for safety reasons. But I would still have to get up there. Safety reasons, Kelvin. Nobody's allowed. It's crumbling. Look at the erosion under here. If I didn't have this drawing, I couldn't make this artificial math question for you. Because often you find yourself walking down the street and seeing a fenced-off crumbling tower and desperately needing to know its height. My son was at scout camp this week. I will let you all know that the Boy Scouts are also being ruined by all of the same things that are ruining your people's education. The scout leader wanted to teach the kids how to make a stand out of sticks so you could hang stuff on it, put your wash basin in it, stuff like that, which would requires you to lash sticks together. When I went to Scouts, this is how that would have gone. We're going to make a stand by lashing sticks together. Okay, this is how it goes now. How many of you guys want to lash some sticks together to make a stand? And they leave. So I said to the Scout guy, why are you guys doing that? Because that's the new direction that Scouts has to take. Choice in everything. So you take kids camping and their choice is to sit and do nothing on a log or learn something new. And if they choose sit and do nothing on a log and commune with nature, that's what wins? Yeah. He was depressed about it. Jenny M. Go with that lovely lady out there. She will take good care of you. You're choosing not to? What? What's spelt wrong? It's the dude's name. Holy Joel. Sorry. Oh, wait, Joel. I'll make it more, acceptable to your white North American standards here. Sorry about that. Bob. There you go. Oh, okay. Wait, you're right. Wait, sorry. Jen. Unbelievable. It's okay, Joel. Of course. Everybody, they all look the same, right? Well, you know what happens when you assume. One of my favorite things to do is when I go order Mexican food in the States, because the servers are all actually Mexicans. They always screw something up, because you order so many different things, right? And they bring out the food, and they always screw it up. And I always get to do this joke, oh, that's okay, all us gringos look the same. All us gringos look the same, because that's white, that's what Mexicans call us. We're white. Or if you're in Costa Rica, it's all you gauchos look the same, or wherever you are. So it's yeah. Every other language has a word for white person. Some of them are less flattering than others. Yeah, cracker. Yeah. In Shuswap, it's that, I believe. Sema. I think that's how it's spelled. There's sevens in a lot of native languages. I don't really know why. All right, so the lovely Ammon, a man is standing at point A. There, I drew him. What? He's a she? I hope there's one of them there gender-neutral bathrooms in there. There we go, and now it's okay. Can't go into that bathroom, though, because I'm not either of those things, so I don't know where I'm supposed to pee. I'm just going to go pee in this garbage can. Anyway. I have a gender-neutral bathroom. It's in my house. Like you all do too. It's not a big deal. There's stalls, Joel. There's stalls, Joel. Joel, okay. Let's do math. Find the height of the tower. Okay. What do I need to find the height of the tower? A ruler. Now you're sexist too? You need a man to measure something? Joel, you are digging a hole, brother. Women can measure stuff. Haven't you seen that movie where the black ladies put the rocket ship into space? And if it wasn't for them, there would have been not a moon landing at all? They helped. Like everybody helped. What? Oh, Joel thinks the moon landing happened in a basement in Hollywood, doesn't he? Right, I forgot about that. Okay, so guys, seriously, how are we going to do this? If I'm going to find this height, what do I know about this angle? It has to be a right angle, yeah? So if I'm going to find this height, since I know this angle, what else do I need? I need one more side, don't I, Kelvin? So if I had this side of x or this side of y, I could do this, yes? I'm never going to find x, am I? No, because I have no information for this triangle. So I got to concentrate on y. How can I find y? Do I have side angle side? No, so cosine law is out. Because I don't have all three sides, and I don't have side angle side. Can I do sine law right now? I can't right now based on this information, can I? Because I have no pairs. But I do have a pair, don't I? Because if this is 31, what's this? 149. And if I know two angles of a triangle, do I automatically know the third? What is it? $13. Now, do I have a pair? What is it? Sine 13 over what? 20. And sine 18 over what? Y. Now do I know y? Of course I do. Once I know y, I can easily find h. How do I find y? 20 sine 18 over sine 13 gets me y, correct? Now Joel has gone ahead and used his calculator to get what, Joel? Exactly? Stop. That's the point I'm trying to make. He's rounded it here. But his calculator is showing him 27.476 ... right? Since that's on his calculator, and since he hit equals, the A and S button will give him that until he hits equals again. Now here's one of the major mistakes you guys make. Remember how your teacher always tells you to show work and you say why? This is why. You're not doing the work, but it organizes your thinking. In this triangle now, I have 27.5 and 31. I need the height, right? Which is opposite 31, and I have a hypotenuse, yeah? So I'm going to be using sine of 31 equals opposite over 27.5. But what is that 27.5? Really, it's this 27.43 whatever, yeah? So I'm going to need to do 27.5 sine 31 to get my height, yes? Now, since you've written this out and that number is sitting right there, what is the only thing you need to do with your calculator? Hit times sine 31. And what do you get? And that's where you should round. Does everybody understand? Now remember, two things when I say this. In my math class, does this matter particularly much in my class? I am much happier with you being good at all of the concept. Understand? However, some of you may be going on past high school in either math, physics, chemistry, something like that. And that kind of exactitude might matter then. Do you understand? So that's why I harp on and I belabor this point right here without actually making it necessary. Do you know what I mean? I want you to be aware that those numbers make a difference. Your entire lives, you've been told to round off to a certain amount of decimal places, so much so that you do it all the time. As soon as you see decimals on your calculator, you start rounding. A lot of you still round wrongly, but I won't get too angry about that. Except to say I should send you back to your grade 3 teacher, and she will say, "Oh my goodness, I taught you how to do this better than that." Assuming she was a vicious old nagging wife like I had for a grade 3 teacher. Classic grade 3 teacher. "Where are my glasses? Some of you stole my glasses. Where are they?" "They're on your head, Mrs. McDonald." "No, they're not. If they were on my head, I would know." "Why didn't you tell me they were on my head?" You couldn't win with Mrs. McDonald. She was a lovely woman. She was a terrific woman. Lovely teacher. Thank goodness. Anyway, so is everybody good? All right. So let me make sure about this. All right, so I'm still recording. Good. Let's, on your book, it starts on page 177, but it's another photocopied textbook page. you need to do 1, 2, and 3, 2 of them. I don't care which 2, right? So there's A, B, C, D in one. Oh no, it's A, B, C, A, B, C, D, and A, B. Do a few. Okay, I don't really care. Make sure you do some. And then in 4, I want you to specifically do C, D, and F. Of course, you can always do more. Oh, no. Everything on this page would be fair game. The last page I gave you that looked like this, I only wanted you to do part of it because I hadn't showed you the other part, right? I want you to do 5. Yeah. I don't want you to do 6. I want you to do 7. I want you to do 9. I want you to do 14. And let's try 19. And that's it. Now guys, listen up please. I am going to give you a warning that on your next quiz, because we've quizzed on unit circle trig, your next quiz is obviously going to be sine and cosine law, yes? It will happen on Wednesday, okay? So you're quizzing on sine and cosine law Wednesday. And I'm giving you fair warning, every question comes from the last 2 textbook pages. Okay, it's going to be a question that I haven't assigned to you, okay, officially assigned. But every question on this quiz is coming from those last 2 pages, all right? It will have sine law, it will have ambiguous triangles, and it will have cosine law. And in both of these, sine law and cosine law, you will need to find angles and sides. You will not have to memorize the cosine law nor the sine law. They will be written on the board for you. But you need to know how to rearrange them and how to use them. Joel. Yes. Okay, but I'm not giving it to you until Wednesday. So we can go over all of these that I just assigned, and tomorrow in class, I've got a sine law and a cosine law worksheet for you. Okay, that we will work on in class, totally in preparation for our quiz. Okay? That's what we're doing in class tomorrow, the next page in your book. Everybody good? All right.